Hello everyone, my name is Darpan Bhaviskar and in this video I will be talking about virtual machines. I will be talking about virtual machines, the OS, the advantages and the disadvantages of virtual machines, the hybridization between containerization and virtualization, etc. etc. So let's deep dive into this topic. Uh, so let's talk about what is an operating system OS. So it is a middleware between user programs and system hardware. Now, what is a middleware? Middleware is a software which acts as abstraction layer between any hardware and the user. Not user application software, but it is a system software. Examples of operating systems are Linux distros, Windows, and Mac OS. It manages the computer hardware, the CPU, main memory, input-output devices, mostly the hard disk, network card, the mouse, keyboard, etc. User application do not have to worry about the low-level hardware details here. The operating system has a kernel plus some extra useful softwares. The kernel is the core functionality of the OS. Kernel is basically a traffic controller in the operating system. For example, there is a user program, and if the user runs that user program, it passes through the kernel. It passes from the user space to the kernel space, and all the hardware components required to execute that uh, system call is done by the kernel. For example, handling the input-output devices, then using the memory, CPU, etc. It is done by the kernel. Other useful programs like shell commands on the shell, other utilities like that, users interact with the OS. So as you can see in this picture, this operating system is a middleware. It's a middle abstraction. It's a layer between the hardware devices and the user program here. So this was the brief about an OS, that is operating system. So let's move on to the next page. Let's talk about virtualization and cloud computing. So first of all, what is the cloud? The commodity servers with lots of computer and storage connected with high-speed networking located in data centers. So a cloud is nothing but a lot of computer which we access and like we pay for them to get the computation done. So that is basically cloud in lame language. Now, what is virtualization? Multiple virtual machines can run inside one physical machine. Virtual machine gives user an illusion of running on a physical machine. Containers are like a lightweight virtual machines. We will talk about that in our later presentation. Virtualization is the building block for cloud computing. Virtualization enables multiple clients share the cloud's compute resources. Multiple users on virtual machines or containers can share the same cloud server. In addition to compute, clouds are also clouds manages large amounts of data. That is the cloud's storage or big data systems for efficient storage and retrieval of data. So let's move on to the next page. Now let's talk about hypervisor. Hypervisor or virtual machine monitor is a piece of software that allows multiple virtual machines to run on a physical machine. So you can visualize hypervisor as a simple software layer which creates and runs multiple virtual machines on a single physical host. Multiple virtual machines running on the physical machine multiplex the underlying machine, similar to how OS multiplexes processes on CPU. Guest OS expects complete control over hardware, but the hypervisor or VMM must multiplex multiple guest OSs on the same hardware. How? So, what is the core function of a hypervisor? So, it allocates CPU, memory, and the hardware resources to multiple guest OSs which are running on the same physical machine, and it ensures complete isolation between the guest OS and security between the guest OS, and also smooth functioning and the hardware resources, transactions between the physical machine and the virtual machine. So as you can see here, hypervisor acts as a middleware between the physical machine and the virtual machine. So let's move on to the next page. Let's talk about virtual machines. So a virtual machine uses virtualization technology to abstract the hardware of a physical machine. For example, its CPU, memory, storage, etc., into a virtual environment. This is managed by a special software called as hypervisor, which we talked earlier, which allocates system resources to multiple virtual machines. Each virtual machine behaves like a separate computer, even though it's running on the same shared hardware. It includes a virtual CPU, it includes a virtual memory, it includes its own virtual storage, and a network interface card through which it interacts with other guest OS on the same physical host. Let's take an example. When you run a multiple processes on a regular OS, they appear to have separate CPUs and memory thanks to CPU scheduling and the virtual memory. A virtual machine extends this illusion to the OS level itself. So this was a very simple example to understand the concept of virtual machines. As you can see in this image graphics, there is a low level which is the hardware. Then our host operating system comes on top. Then on the top there is a hypervisor, which is the virtual machine software which runs and creates the virtual machines. And on top of hypervisors, we create our virtual machines. In this image, there are two virtual machines. In the first virtual machine, we have, let's say, guest OS blue, and on that we are running an app named app1. And in another virtual machine, we have a guest OS of another different type, and we are running some applications here. So as you can see, we have containerized our applications and our tasks into two different virtual machines. So it provides a complete isolation and security between those virtual machines. So this ultimately using virtual machines in development has some benefits, and we will talk about that in the later phase. So let's move on to the next page. Now let's talk about containers. So what are containers? So while a container is a software that allows different functionalities of an application independently, while applications running in a container environment share a single OS, while containers virtualize the operating system or the software only. While the size of the container is very light, generally a few hundred megabytes, though it may vary as per use, while containers take far less time to run. So this is the key difference between a virtual machine and a container. You may have hear the name of Docker. So what is Docker? Docker is a containerization engine, and it has its own container hub. So what is container basically? So let's say you have a project and you have to you are locally developing your project and it is running fine on your own system, but you have to send that project to some another, let's say to a tester to test the project. So you will just send it by any means, let's say by GitHub, and that person will clone it, or you will send it by maybe zip. So what will happen in that case, that the tester guy will not have the required dependencies in his system, or there might be some inconsistent versions of the dependencies that the tester guy might have in his system. So because of that thing, your project will face some error, some probable error while running or while executing that program. So that problem is tackled by the container. So what a developer does, he makes a container, then he stores his project and all the dependencies required for that project in that container, and then he containerize it and then he gives that container to the tester so that the tester can test and debug and do the later phase work on that project. So that was a very basic idea about container. So as you can see here in this graphics, we have a hardware. On top of that, we have a host operating system, and on top of that, we have a container engine. So in that container engine, we can make multiple containers, and as these containers are not a whole OS, so they are not heavy in size, and therefore they are very lightweight. They only contains the dependencies and the only required um OS for that. Means there is a very minimal kind of OS which is in the container, which is only required to run that particular thing. So let's say we have three containers, and in one container we are running some different application, in other two containers we are running some different application. So it provides a sense of isolation and a sense of abstraction in your work. So that was all about containers. Now let's move on to the next page. Now let's talk about containers on virtual machines. So it is a hybrid approach. Docker or the containers run inside the guest OS on virtual machines. So in this thing, let's say we have a physical host machine, and in that we have installed a virtual machine. And in that virtual machine, we are running containers. So this is like a double layer of abstraction which we are doing in this case. Now why we are discussing this? So 2 to 3 times more applications per physical server than VMs alone. Container orchestration manages multi VM clusters and combines the VM isolation with container efficiency and portability. So, this hybrid approach increases the memory overhead if you have a very system with not very high-end require with a very high-end specifications, then this might not be the best option for you. But this uh, this hybrid approach provides a very uh, great sense of security to your tasks because you are running your containers on your virtual machines, and your virtual machines are isolated from each other and the physical host itself. So that was all about containers on the virtual machines. Now let's move on to the next page. Let's talk about some advantages of virtual machines. So the first advantage that we get obviously is isolation. Each virtual machine is fully independent and secure from others. The second one is flexibility. They run different OSs on one device. So you can run virtual machines of Windows, of any version of Windows, of Mac, of Debian, Ubuntu, Kali Linux, Arch Linux, etc. etc. Then obviously cost and energy saving. Multiple VMs can run on a single machine. As you can, as you know that in Liquid Galaxy, for the task one, we are using three VMs on our physical hosts. Disaster recovery, easy to backup, clone, and restore. So there is a concept in VM about the getting the image and snapshot. So it is a very good thing to get a backup. The next one is legacy support. Run old apps on modern software. The last one is simplified testing, perfect for software development and security testing. So as you can see, there are some benefits. Operational flexibility, it reduces the overhead. There is a centralization factor. You can scale it, and there is a disaster recovery factor. So let's move on to the next page. What are the use case of Liquid Galaxy in context of virtual machines? So the Liquid Galaxy uses three virtual box machines in the task one. LG1 as the master, and LG2 and LG3 are acts as slaves, running Ubuntu to replicate the panoramic Google Earth visualization. Master controls the navigation, and the slaves sync via SSH/UDP for seamless multi-screen rendering. What are the development benefits that we get from this thing? So we do not need hardware. We do not need this much amount of screens to do our tasks. So we can run the full LG rig, the master slave sync, with a KML refresh on any laptop for app testing. Then for troubleshooting, virtual machines allow debugging issues like slave startup. So that is the development benefits here. What are the technical challenges that we face? The virtual machines introduce overhead, pass-through needed for Earth rendering, but provide isolation for safe experimentation. So virtual machines consumes a lot of hardware resources, mostly the memory here. So running a lot of virtual machines on your PC or your physical host might not be a great idea. So let's move on to the next page. Let's talk about let's talk about some best practices that one can adhere while working with the virtual machines and setuping it. So the first is CPU configuration. 2 to 4 cores per VMs for typical workloads. The Liquid Galaxy Slaves needs 2 core minimum for the Google Earth rendering. Then reserve some cores for critical virtual machines. Don't oversubscribe beyond 1.5 times the physical cores. Match the guest CPU type to host. Avoid migration issues across different CPU generations. Uh, the next one is memory allocation. Leave 4 to 6 GB for host OS and allocate the remaining RAM to virtual machines. The Liquid Galaxy virtual machines for the master LG one, give it about 4 GB of RAM, and for the other slaves, you can give up to 3 GB each for the virtual machines. Then enable dynamic memory, but set hard limits to prevent ballooning contention. And remember the rule of thumb, 80% of the total RAM to VMs, never overcommit beyond 90%. Just set a limit of 80% of your total physical RAM to the virtual machines. If you go beyond that, then your other processes might get affected. The next one is the storage. Use SSD for virtual machine storage, critical for the Google Earth input, disk input and output. If you have SSD, then store your virtual machines addresses into the SSD because they are fast than the hard drives. So ultimately, it will be the boot up phase will be very faster. The next one is separate VDI files by workload type. Avoid single massive VDI file, enabling the disk trimming for space reclamation. So these were some of the best practices and advices while setting a virtual machine on your physical host. So let's draw a conclusion for this presentation. So virtual machines solves some critical infrastructure and development challenges by maximizing the hardware utilization and providing isolation between the virtual machines. So the core reason of using virtual machines is hardware efficiency and the use of hardware resources. It runs about 10 to 20 times more workloads on same physical machine by sharing the CPU and the memory resources, and it ultimately reduces the costs of the resources need, and it also does cost saving. It eliminates the need of physical server, and one can just install required virtual machines on a high-end physical server and work on that rather than buying some physical setups for doing his work. And the next one is there is zero downtown migration, means you can live migrate virtual machines between hosts. So that is a very good thing here. And also we can store instant backup or snapshots in the case the lingo used is snapshot here. So there is a very good backup policy in the virtual machines. And from the point of security and isolation, it provides a very complete isolation. Malware in one VM cannot affect the other VM or the physical host. So that is a very great thing here. Then it provides a separate environment for developing, testing, etc., and even for production. So that was all about virtual machines. Thank you.